tonight, what I'd like to do is introduce our expert for tonight, is Mike Bugembe. Rather than doing death by PowerPoint, which I'm sure you all have in many guises in different places, we thought it might be interesting just to have an in-depth conversation with Mike about data, what makes him tick, his experiences to date. Mike's career is a long and varied career in data. He's a data evangelist, a little bit like myself in some ways. Started in De Beers, worked at Expedia, was Chief Analytics Officer at Just Giving, and we'll probably touch a little bit more on terms of what he achieved there. Author of a book, Cracking the Data Code. We've actually got 5 copies here, so if we get some good questions from the audience this evening, Mike will distribute those a little bit later. And that's basically it. So, Mike, sort of just thinking about your career, what actually started you on the path to data and AI?
So firstly, I didn't want to interrupt, but you missed like 5 years of my first part of my career. Started with Accenture before I went to De Beers. So I did a few years there as a consultant, hopefully selling you data warehouse projects. You know, those 18-month projects that never end? So but I think the question was, how did I start? I think very much like a lot of people in the space, it was Hollywood was a big driver for me in the 1980s as a child. And I think I remember very clearly there were 2 movies that really stuck out for me, or 2 things that I watched. One was War Games. I don't know if anyone has seen that. So that was a little chap hacking into the government database. And, you know, you took your phone at home, and we had a little Apple IIe at home, and you were just trying to get that modem sound. I didn't even know what a modem was, but that was the beginning of, let's say, my coding experience. We even tried getting my sister on the other end of the phone, and I was like, just beep like the phone and see if it does anything. So make that modem sound, see if it, but it didn't really work. The second one was so we called it the Bionic Man, but I think it was a program called the $6 Million Man or something like that. Yeah, and is that what it was called here?
Yes, it was, yeah.
So that was the second one. So that really introduced me to the whole thing of machine plus man and got me really excited. So so I think it was that, and then I just never left the computer. I think I made my first game when I was about 9 years old, and spent a lot of time coding. I come from a fairly traditional family, and so when I was picking my degree at university, I remember telling my dad, I'm going to do computer science. And he said, Mike, why don't you do a proper degree? Right? Traditional African parents, and I kind of knew what a proper degree meant. It was medicine, engineering, or law. I think economics might have squeezed in there a little bit as well. So I chose engineering and did electronic engineering, and really that was where I actually think it was the best thing that I ever did, because I covered a huge amount of mathematics. My thesis was really around Fourier transforms and coding Fourier transforms in MATLAB, if anyone can think that far back. And that was my beginning of the whole data journey, because I built a device that you could basically use sound waves to recognize the shape of a device, but also then translate those the Fourier transforms backwards to try and understand what the shape was before. So the use case was like car accidents, to almost retrodict what happened in an accident just by using that device to try and understand that. And I remember very clearly my lecturer said, one of the reasons why I won't give you a first is because you need so much more information to be able to understand what the shape was before. Things like the weather and all of this. And so this is 1999. Big data wasn't in the same way that it is now. I really wish I could go back and just say, well, we've got all that data now, so give me the first, but I'm not too bothered anymore. So yeah.
So I think in some ways, I mean, you said you described your electrical engineering background there. I mean, I've got a mechanical engineering background, and in my world of data, I tend to be kind of software agnostic and thinking more about how to achieve the end results rather than what is the means to get there. I mean, have you got a similar take, and is it the end results, or is it what the bit in the middle, all that clever code? What do you think is important?
I've got to be really honest and say it was at different times in my career. I think early on it was the bit in the middle was very exciting. As with many data scientists, you will find that we're intellectually curious. So tackling some of the bigger problems, being able to work with some of the big algorithms is the one that's really interesting. I'll give you an example if that's okay.
Yeah, sure.
My time at Just Giving, I remember we were using data to basically see if we can make the UK more generous. And we were successful actually in many interesting ways. But then there's like some ethical boundaries, which we can probably talk about later as well, in terms of how the machine was able to get you to either donate more or fundraise more. But the team, we'd come across a genetic algorithm that we could use to try and work out what donation prompts we should show users when they press the donate button. And the team were over obsessing about how to use this genetic algorithm because it was newer at the time. It was really, really exciting. But we could get the same result, in fact, if anything, a better result with just a linear regression equation. This was not exciting for the team, right? You know, they wanted to work on the genetic algorithm and sit there for 3 months doing it to end up getting the same result that we could possibly got within 2 weeks. So I can understand where they're coming from, because initially my excitement was really in the middle in terms of working with those algorithms. But this more senior that I got in my career, the more clear it was that we had to deliver true business value, a real return on investment, and data science is expensive. So in order to do that, we had to, I now much more focus on how do we directly link all of those data activities to a metric that the business is passionate about and cares about. That form, what the CXOs or translate as valuable, right? So whether it's more users, whether it's retention, whether it's profit, the thing that keeps the team in place, if you like. And, so yeah, that's what I would do.
Presumably some of those metrics, if you're trying to get the CFO on board, one of the key metrics has got to have a pound sign in front of it, or a dollar sign, or a euro sign, whichever.
Yeah.
It's sometimes people think more in terms of percentages, they think more in terms of, let's say, absolute numbers.
Yeah.
How do you find it to get some of your teams as programmers to think in terms of that financial side of things and getting them thinking in terms of pounds and dollars?
It's a good question, because you know, as let's say a chief data officer or chief analytics officer, you've got the job of keeping the team excited so that they can do exciting work. Otherwise, Facebook will take them or Google will take them, and I had that challenge every day, by the way. Good data scientists are always hunted down, if you like, constantly. I think they said it was a really crazy stat that 80% of the world's data scientists work for the 4 horsemen of the internet, if you like. So, you know, they all get poached. So you have the challenge of keeping them excited, but you do have to deliver business value to the shareholders, or, you know, or however your organization is structured. So it is a difficult balance to strike, but it is essential, I think, because at least with a lot of the organizations that I've consulted with, your patience can run thin if you're not getting results that move the business forward. It's an expensive team. They look at data in a very different way than most anybody else within the organization. They also tend to be very disliked, because you've got developers who are, let's say, developers, but they're not doing data science. And then you've got people who feel that their jobs are being threatened. And I've got so many stories of, you know, when you come in and you're like, well, we can do an algorithm that does what you do 90% better. And you know, and you can't really compete with the base cost of electricity. You know, and so, yeah, I'm not sure. I've forgotten your question in my rambling. Sorry.
No, it was about trying to get the data scientists thinking in terms of pounds as the metric, or pounds, dollars, euros, whatever is the metric, rather than just whatever. And so I think we covered, but I think that kind of leads in. So what about major successes in your career? And I think probably in Just Giving, in terms of some of the stats you've got there in terms of how you transform things, that'd be useful just to explore those a little bit.
For me, that was my biggest, most exciting time. See, so the mission at Just Giving was quite ambiguous to begin with. So it wasn't a very clear business problem. It was one actually that worked in terms of recruitment, because we were solving generosity, right? You know, like how DeepMind is solving intelligence. So painting it that way meant we didn't really struggle to hire. But where that was exciting for me is we went through the full hype curve that a lot of these organizations go through, where there's a lot of excitement, a lot of investment. You know, the shareholders are interested. You know, the investors are like, yes, we're doing data science. And then comes 8 months down the line where they're like, well, okay, it's the most expensive team in the company. Where's the value, right? And then for us, it's like, how come donations aren't going up? And how can you prove and demonstrate that the work you're doing is the one that's increasing donations, not the existing teams that we have in place? So we went through that. Why I cite that period of my life is because we went through that full cycle where the team was really under threat, building exciting stuff, but it couldn't translate into tangible value that they could see. And then going through that process where I remember sitting down thinking, it was in the office late at night, and I said, I'm going to stalk my entire network, all of my Facebook friends, Google friends, Spotify friends, everyone I know. I didn't know anyone in Netflix, but I managed to find someone, and sat down with them for about an hour each and said, what are you guys doing differently that we're not doing? I'm so glad I did that, actually, because there was a clear signal amongst each of those organizations of activities that they were doing that a lot of us weren't doing, and a lot of other organizations I came across weren't doing, and even we weren't doing. So having the great data science team and an objective wasn't enough for us to see success. And then we basically codified those 5 things that I could see within those organizations. That's what made it into the book. And interestingly enough, very few of them are, in fact, almost none of them are technical. In order to see that success. So you can have a really superb team, but the challenge of getting value and even linking what we're doing to real business value was more of a business challenge than a technical one. And then going over that hump and eventually building a suite of algorithms. Once we'd got that, that sort of 5-step process, our algorithms were generating in excess of 20 million pounds worth of donations a year, really, really quickly. They were transforming the way giving was. So we had 10% of people who would come onto the platform, make a donation, and then come back. But most people, 90% of people, would never come back, right? We would never see them because they donated to a friend and that was it. And we moved to 56% retention, where we had lots of people coming back and engaging with causes that they really, really cared about. We had, from, I think it was 30% of people who were putting targets on their fundraising pages and just about reaching them, to 98% of them putting targets on their fundraising pages and raising roughly 7% more, which is big on a £400 million business, than they would have done before. And eventually the company sold for, we sold the company for 100 million at the end of 2017. And what was exciting for me and a big milestone for me was data science and the suite of algorithms that we built was if you like, the center of that acquisition. So yeah, that's a long-winded way of saying that's my
that's
mode.
good. But a lot of what you're doing there, using the data science in effect to facilitate behaviour change from the donors. And was it just, it must have been a little bit more than just clever data science. So how much of it was also about the branding, the marketing, how you get the user experience right, as well as the data science behind it? So did you have teams working together between the scientists, the user experience, the web developers?
That is a great question. You should get a book for that question, actually.
I've already got the book, by the way.
So yeah, there is this notion that sometimes you can build a fantastic algorithm which you've trained a model, you've got it to work, and it seems really effective, right, in testing, and you deploy it into production and you don't typically get the same results. This is real, right? So if any of you haven't started this journey, you can build some great algorithms. They will work fantastically after you've trained that model, deploy it to production, and it doesn't do the same thing. And one of the interesting things we came across was we needed to understand people, right? So this was the machine working on a consumer-driven platform, and it was just going, just that's the results. And so, of course, user experience came into play. But we really struggled with our UX team because they didn't understand machine learning, and they didn't understand what it was we were trying to get the machine to achieve. So we taught the entire data science team behavioral economics, which was really interesting because you're looking at it from almost a very linear process rather than just a philosophical one, so you're trying to understand how people make decisions. After all, we always say data is for decision making, and we thought, actually, then let's understand how human beings make decisions and see where the machine could really make that improvement. So we added a layer of behavioral economics to pretty much everything. So I'll give you a quick example. When you create a fundraising page on Just Giving, we wanted you to put a target on your page when you decide you're making the decision of how much do I think I can raise for this cause. Now, most people would put a pretty arbitrary number. If you looked at the distribution, it was fairly random. But then we found that the machine could determine what target you should pick in order to maximize the chances of you coming back and fundraising again, enjoying that activity, and raising as much as possible for that cause without offending people or anything like that. So different people had different maximums that they could raise. Now, initially, the machine would spit out a number, and then we just thought, okay, email it to people. But you didn't get any take-up. We didn't get more people putting that target that we wanted. But in behavioral economics, using the principle of default, if any of you have read Dan Ariely, have you heard Dan Ariely's book, Predictably Irrational? One of the first examples he gives is why does Sweden have, I think it was Sweden, he goes through a whole bunch of Nordic countries, and I can't remember exactly which one. So let's say Sweden and Norway, exactly the same countries. Why does one have like a 90% sign-up rate for organ donation, and the other one has a 12%? And he goes through a whole bunch of countries where the people are similar, the cultures are similar, but they had all these different numbers. And he basically said it's the fact that it was pre-ticked, right? And we as humans we're a little lazy when it comes to some of those sort of things. There's a whole bunch of behavioral economic principles that he came up with. There's about 250 different biases that we had to try and understand and learn. And so we just used that principle and basically pre-populated the target field. What was interesting is that you could pre-populate that with whatever number, and most users accepted it. But then it had an impact on retention. It had an impact on them succeeding in reaching their target and so forth. So the machine was really valuable in being able to work out what that number was. Behavioral economics taught us how to make sure that we went from 30% to 98% of people.
That's interesting. So just thinking about teaching your data scientists to behavioral economics, did they see that as, in effect, enrichment of their career and expanding their capabilities, or did some of them feel threatened by that and the fact they just wanted to do data science? Were there some behavioral people issues you got with your data scientists?
Yeah. Has anybody here got a team of data scientists? Yeah. Okay, so a few hands. Just give you a picture on what a typical... I can feel comfortable saying this because I used to be one, but some people describe us as being a little on the spectrum, right? So there tends to be a certain type of person who is your typical data scientist. We had one guy who used to start a sentence like this every time he was working with the business, and he came up with something really interesting, a new insight that they couldn't fathom or understand. He would start his sentence like this. This is even to the executive team. Let me tell you how stupid you are. And then he would carry on with his sentence. And you'd sit there and you just think, oh my goodness. But he didn't even think there was anything wrong with that. And we had quite a few of those really interesting characters where we tried to teach them presentation skills and would put them up in front of the company. We used to have a shindig every Friday. And the moment the data scientist stood up, you could see everybody just go like, you know. So that you know, let's say we have different strengths, right? And so I thought, okay, let's try and teach them when we went through this behavioral economics thing. And a lot of them were like, no, not interested, won't add any value. But then when we went through almost the logical structure of it and how you could effectively almost codify a process to get someone to, a user to act or to comply to an action that you wanted them to do, and that it was repeatable, this really excited them, because that's quite mechanical. I do X, Y, Z, and this is the result, X% of the time. So that was really interesting. But I'll tell you something else, actually, as part of that. With this individual who used to talk to senior leadership, I had to put a filter between him and anybody else within the business. And we thought, okay, let's try and teach them communication skills. So we went on a 2-day communication course, and that was an absolute failure. It did not work at all. One of the person who was teaching the course, who really struggled, and I felt for him because he was like, I've done this so many times. I've never come across a group of people where this has just been an abject failure. And he said, perhaps there's something about trying to make someone something they aren't, right? And so these guys are really good at building algorithms. Why not let them continue to do that, right? And sharing to a group of people that are interested and speak their language and enjoy to do that. So we went the other way, and we started to teach the business about artificial intelligence to try and bridge that gap. And that was way more successful, way more successful. So,
yeah, that's interesting. Yeah. So in terms of that challenge of influencing the stakeholders in the business, I think you were suggesting there that actually try and bring two sides together, rather than get one side to be what the other one isn't. So, or is it maybe worth having somebody as a spokesperson for the data scientists? But does that devalue what they're doing?
No, I absolutely believe in having a spokesperson, because at least a lot of the data scientists that I've worked with, didn't have a requirement to speak to people. It wasn't something that if you said, "Oh, we're gonna put a business partner in between you and the team," I've never encountered a data scientist who said, "No, I don't want that." They're actually, "Yeah, that's fine, because then I don't have to talk to them, and I can just get on with what I'm doing." And so, when a lot of people think about putting a data science team, I think it's absolutely necessary to have that translation. I think they call them business partners. We had a business analyst, and these are typically people who perhaps can't write an algorithm to the same degree, but they can speak enough of the language. They are mathematical from some sort of numerate background, but typically they may have been a management consultant, so they're quite good at talking to the business as well. It's really useful because otherwise you get an us and them mentality, and as I said, jobs are being threatened. You go to a marketing team, which we did, whose job it was to send emails to users to try and get them to come back. And you have all the numbers of how successful they were, how many dropouts there were, how many people came back, and how many people made a donation. And we let an algorithm loose to do the exact same thing, and it was better, miles better in every single activity. That's threatening, right? So how do you explain that to them as it's not coming to take their jobs away, but it's perhaps going to enhance what they do? I described it as take the robot out of the human and allow them to be even more human. So the creative aspects of that email and things like that they could do.
Yeah, so there could be an argument that for some of that they were getting quite comfortable with doing the processing they were doing on a week in, week out basis. And the AI was, like you say, taking that away, allowing them to then demonstrate their expertise in marketing or whatever.
Yeah.
I mean, is that extensible in other disciplines, you think?
If I'm really honest, I'm not sure in every discipline. I think there are, when we talk about AI coming to take jobs, I think it's real. Jobs will disappear because the machine, I think I made the statement, you can't compete with the cost of electricity for certain repeatable tasks. But I think there will be net gain in the whole jobs market. So a little like the internet, so certain roles disappeared, but when the internet came on, there was a whole bunch of roles that we couldn't understand or we didn't know in advance that appeared, right? And there's, honestly, there's going to be so much we have to try and make sure this machine is accurate. So I'm talking a lot, so stop me if I can go on this. So take, for example, the machine only learns from data, so AI learns from data. But if you've coded bias inherently within that data, it will make mistakes. So an example that I often give is if you look at Amazon built that algorithm to try and see if they could create a machine that would analyze CVs and increase the diversity of hiring. But then that algorithm worked in testing and so forth, but then it would penalize anybody who had the word woman in their CV, right? And that's purely because of the data set that they had. All their previous developers were men, white men with long black hair that listened to death metal, all right? So in terms of telling a machine, find me the best developer, and here's the data to coach you and train you on that, that's what it's going to do. So, we need others in the room, and there's so many examples. There's examples of when Google's image recognition was looking at black people and labeling them as gorillas, and we've all seen that. Or the passport one where I think it was a Chinese gentleman who went to the passport machine and it said that he should open his eyes, right? So, there are so many roles in terms of saying, whilst data is valuable, we need the humans still to try and address some of these things. We need a diverse group of people within the room to try and find some of these mistakes that the machine will. In fact, from the machine's perspective, it's not a mistake because that's the data you gave it, but even to clean up some of the data that was being fed into the machine. So I think there are rules for us.
Yeah. So how do you encourage diversity, both in terms of the data scientists, the teams who are, if you like, creating the machine, but also making sure there's like you say, diversity in how the AI, in terms of how the analytic works. So how do we encourage that diversity?
For me, at the moment, I'm really big on education. So there are lots of, I think the government, universities, and academic establishments are doing a lot to try and increase the number of data scientists to fill that gap. Unfortunately, we're in a period where if you just say you're a data scientist, you get a 0 added to your salary, right? So there are a lot of pretenders, if you like, people who can't really do the job. But education is really important because even when it comes to hiring, we've gone through a period where I've met with executives that are like, oh, we've got to hire them because they have a PhD. Yeah, you know, and a PhD doesn't mean that you can work with a whole suite of algorithms. You've probably run a regression equation to answer the question that you're answering for your PhD, and it stops there, right? And they're like, oh, we'll get PhDs from a science background, and that should be enough. And it doesn't really work that way. So education for me is really important. As I said, they're dealing with the technical side, and I think there's a lot of things online where you can learn how to become a data scientist. But I personally, I educate executives because there's so much of it is a business challenge, as I mentioned. And if they don't understand, you know, so I partner with consulting firms who will do the implementation and so forth. But coming in and educating the business works really well because they get to understand how it works. It manages their expectations. They get to understand who to hire. You help them try and find the right use cases rather than, I hope no one's working with chatbots here, but everyone's saying chatbots. It's the new shiny thing. So every executive says, I want a chatbot, you know, but like, yeah, that's not necessarily the low-hanging fruit that's there. You know, you know, they execs like big shiny things apparently. So, you know, so to just take them on that journey so they can understand that and then understand the role that they play in making sure that the algorithms work, right? This is the one area where when I was younger, if I would walk into an organization and someone would say, I've been doing this for 25 years. And I'd be like, well, you're not going to be doing it much longer then, you know, and stuff like that. That's how we used to get excited. But then increasingly learned that actually those individuals are so valuable because they've got data that we might not have captured in the database and therefore haven't taught the machine. And so they are increasingly valuable to that. So making sure that execs know that those individuals are so essential. I'll never start a data science project now without a domain expert that has a real length of expertise because they can spot some of those things that we perhaps just didn't capture the data. So the machine doesn't know how it works.
Yeah. So that actually is quite a good lead into the last event that we had here was on knowledge management. And in fact, we're videoing this event, so that will go up on the BCS YouTube BCS member groups channel on YouTube. The video for the knowledge management one is probably going to be up within the next few days, but that actually is a really good link there in terms of what Mike's suggesting is that it's another thing that you need to think about how you manage that knowledge, how you do the succession planning, how you harvest the knowledge of those people who've got the 25 years experience, and then actually be able to then replay that and keep that in the organisation. So it's a really important thing to do.
Let me add to that as well, actually. So there are a lot of studies that have been conducted out there that you can see companies that have invested in AI, companies that haven't. And there's production differences, there's savings differences, there's efficiency differences, there's accuracy differences, massive differences. On the people side, what's really interesting is I looked at a couple of, you know, like top marketing officers and top this and top that in different career disciplines. And every single one that was in the top 20 had a pretty robust understanding of AI, which means even for the jobs that we've got right now, even if you're in a business or a commercial position, if you don't understand how this thing works, you're less employable than someone in your position who understands how this thing works. It doesn't mean you have to know how to write an algorithm, but you know, understand what it can do, what it can't do, right? Understand how to find a use case, which is really challenging. It's not so easy, but how do you find that use case that is different to your competitors? The other thing that execs don't know is, oh, my competitor is doing churn, so I'm going to do churn. And you get different results, right? And that's because of really subtle differences in the data, in the team, and even in deployment. That will mean you'll get completely different results to your competitors. So I think education is going to be, you know, a lot more non-technical courses, I think, are required for execs and for all of us in our careers.
I'm just thinking about the execs. So what sort of tips can you share with people in terms of getting, if they're trying to sell the idea that execs need to treat data more seriously, what sort of messages, what key sort of takeaways can you give there that people can perhaps share with some of their teams to get, like I say, data treated more seriously?
Okay, so I think one of the big ones is there's a misconception that we can wait, there's still time, and I'll be okay, my company will be okay. I'll give a couple of examples on that. Firstly, there's a great blog that you should all read called Wait But Why, and he talks about how quickly AI is changing. We tend to think of things linearly, right? But it's much more exponential than that. So he gives a great example where he says, if you took someone from 300 years ago and brought them here today, you could have loads of fun with them, right? So they'll look at tubes flying in the sky, metal tubes, and you can relive a symphony that happened 20 years ago, you know, and watch the whole thing again, talk to someone across the world. And he came up with, I think it was a probability of death metric, right? So he was saying that that person is likely to die because of just how immense the change is over 300 years. For that same person to have the same sort of fun, they would have to go back to 12,000 BC, right? That's how far back they would have to go, because that's the magnitude of the change. So the change also works within the last 30 years. If you've everyone seen Back to the Future, I'm showing my age. I think they went from 1985 to 55, I think it was, right? And you can see the immense change there. Now, the second example I'll give is Wired Magazine in 2014 gathered a bunch of AI experts and said, how long do you think it'll take for a machine to be able to beat a human being at Go? And they all agreed at the very least 10 years. It was 2014, right? It took 2 years for that to happen. And so the point I'm trying to make here is this whole idea of I'll sit back and wait, it's not really going to affect me, is really, really risky for the reason that it's moving much faster than we expect. And the other point, actually, and this was a paper I saw by the White House during the Obama administration. And they said their biggest concern around the world of AI was that instead of it being one of those technologies that lots of people will benefit from, or lots of companies will benefit from, they actually think it'll be very, very few companies that will benefit from it, because it's those that understand how to play the data game. So they've got strategic data acquisition strategies, those who know how it works, and therefore those who can start building those algorithms. And when you look at it, you can see that companies with those three things are jumping into domains that aren't their normal domain and dominating them, right? So this idea of sitting back is just risky, right? Because it's not that your competitors that you have to worry about, it's some of those others that have all of those, that combination of things. Yeah.
Question down there.
Hi, Faisal Bharti. I work for an insurance firm not too far from here. How did you address the challenge of data itself, the quality of the data? We've got a huge aspiration in our firm, or in our department, to develop this area. But one of the challenges that we have is the actual quality of the data.
Yeah.
And before we can even kick off, we end up trying to standardize the data, improve the quality of the data before we can. How did you address that?
So there's a couple of ways. We tried, just getting everybody to change what they were doing, and that was really difficult. But I found that there was a step change once we educated the business, and they understood what data really, the value that data really, really played, and the actions that they had. So, educating them as part of that was a big, big game changer for us. The other thing that we did was we involved a lot of the data scientists now at the beginning stage of the projects, right? That did a couple of things. It really saved us a significant amount of time in terms of the data going all the way through the pipeline, and it gets to model building, and they're like, actually it would be better if the data was like this, because they were doing that at the very beginning with the developers. So the developers also then began to get a language in terms of understanding that if we had captured this way, it's much quicker and much more efficient for the data scientists. So education, definitely, educating the business. And the big thing when we were educating the business is we were saying, talking about strategic data acquisition strategies, right? So what is your company doing deliberately to get data? So take your sales team, for example, or our sales team. Their job was to partner with other charities, and they're incentivized on donations. So they would never try and look for a partnership that just involved data and no money, right? But until you've done the training, that doesn't even seem like something valuable, and your C-suite isn't incentivizing them on anything else. But we had to change some of those incentives, because they were like, data is so valuable to what these algorithms could do. We have to do that. And another thing in the data acquisition strategy, we were saying, what's our free product? You can look at all the big companies. They have lots of free products that are purely designed to gather data, right? And ask most companies, what's your free data product? And there's a lot that don't have one, right? There's more that are getting them now. So that education piece was really big for us.
I'd probably just chip in a little bit on the quality one, is actually have an agreed set of quality criteria. So your definition of poor quality data might be very different to yours.
That's a good one, yeah.
And if there's agreement then with it, and it might actually take a lot of discussion about actually what is our quality criteria, then you start to have a consistent metric that you can move forward with the rest of the organisation. But those data conversations are really, really important.
Yeah.
So I think
the advantage, disadvantage side of things, what's your take on that risk from a society perspective, from a business perspective, from a national perspective? You know, we look at the likes of China, the likes of Cambridge Analytica. So I think there is a lot of substance in that concern. Like, what's your take on that? Like, only a few will dominate this game and make it, you know, make the most out of it, like in a global scale. What's your
So
take?
I'm not sure if I've understood your question. You're saying, well, is there a risk that it could be used incorrectly,
Yeah,
or?
you mentioned that the White House or the Obama
Yeah,
administration
yeah.
said that the biggest risk is that this will be capitalized
By just a few, yeah.
What's your take on that risk if you think of the business element, the society element, and then the national element? And what I'm thinking of is thinking the likes of Cambridge Analytica, thinking the likes of China with you know, all the things that they have ongoing.
Yeah.
There is a reason to fear that. What's your take on that?
Let me answer this way, and tell me if this answers the question. I'll explain how we've done it. Once you understand the power of what these algorithms can do, it is absolutely essential that you have some sort of ethical framework stroke structure to govern how you use them. I'll give you a really simple example. We had an algorithm that was trying to work out, as I said, what donation prompts to put in front of people. The algorithm soon discovered that for a certain set of users who it could very clearly identify, if you received a donation request at 9 o'clock at night on your mobile phone, whatever we pre-populated what should I donate amount with, you just pressed OK. And so that algorithm was flying. We could get lots of donations, right? Because for a certain type of person. It wasn't released in the end, right? And because we had to have that conversation and say, well, hang on, did they even know they were donating £100? Or did, you know, when they would normally give 10? And you see, the machine just has no emotion, right? So it's just, it won't even consider that because that's not one of the things that we put in. But it was told maximize donations. That was the thing. But that ethical committee was absolutely essential. There was one other thing that came out of that, though, was that algorithm had high interpretability, right? Which is something that you don't often hear when a business asks for an algorithm to do something. They just say, this is what I'm trying to maximize, and that's it. And you don't often see data science teams going back and saying, okay, what sort of interpretability do you like? You know, so the non-functional requirements, I think we used to call them back in the day. And that's one that I've rarely heard, you know. So how much do you want to be able to explain how the algorithm came up with that decision versus how accurate do you want it to be? Because sometimes you have to sacrifice accuracy to be able to explain it, or you'd be, I don't care, just make it maximize, you know, however it does it. And in that case, that would have been an issue. So I think we need to strive for almost pushing for making sure we can interpret why. And sometimes you have to write additional algorithms to interpret why, right? And it takes longer, it adds time to the project, but you have to explain that to the business. So I think the ethical framework is absolutely essential. When you understand how behavioral economics works and the fact that you could code a machine to be charismatic, right? Which is pretty scary, and get people to agree to things, you do have to put that ethical framework in there and try. But it's a difficult question. On the Just Giving one, you have two sides of the debate. One side is saying the cause absolutely deserves the money. You know, and the other side is saying, yeah, but was it free choice? So then that introduced the third one, who was like, do we ever have free choice, right? You know, and there's a whole philosophical discussion there. And even we proposed, okay, we have an algorithm that can work out how much your disposable income was, right? So should we say that if it knows that you could have given 100, go ahead? You know, and things are like, okay, is that a little intrusive? Or, you know, and those sort of things. It's amazing what these machines can do right now, and what these calculations can do.
So yeah, just a useful plug there for another event. So one of our webinars in October was on explainable AI. And so again, that's the recording of that up on the member groups channel on BCF on YouTube. But yeah, there's quite a bit of research and thinking there about how do you make the black box more interpretable to actually understand where it got to and how it got to that decision. Sorry, gentleman over there, you got a question?
Yeah, so we've talked a lot about communication, especially with executives. And is there, does it ultimately all come down to putting a pound sign in front of something, or is there a different way in your mind?
So when those that, because I've sort of formalized the course after that, and one of the things as part of that course is it's called my 6 Ds, if you like, right? So the first one is discuss, which is really to help you be able to sell the idea to the rest of your team. Demystify, which is get rid of the hype and understand how this thing works. Develop, understand the process so that you can empathize with the developers and also understand the part that you play in making sure that that succeeds. And this is the one that I hope answers your question, which is discover, right? How do you find those use cases? And where that became really useful is it moved the whole thing from you selling, this is what you should use it for, but once they understand how they can apply AI, and leaving them to come up with the use case for that, because they understand both what it is, how it works, where they can apply it, and then the corresponding benefit. Takes you a little bit out of that equation, and then they can come together and say, which was more effective for us, because we're the ones proposing these, and it was just hitting a brick wall. But if you taught them and they were like, let's do it for this now, because they now understood exactly how they could apply it. And so we had to create several frameworks to help business users understand exactly how do you get a useful use case for AI. That was effective for us. I don't know if it would be for all organizations, but I found just putting that power again, a lot of it is a power struggle, isn't it? Because the whole thing of a machine taking away your decision capability is some sort of power struggle. And even with use cases and getting people to buy into the whole thing, when we just shifted the dynamic and said, look, you come up with it, we've taught you how it works, you see the benefit, they felt more empowered in their roles as execs to come up with what we should use it for.
Just thinking there, building on that then, in terms of, be interested to get your thoughts in terms of whether the AI, guidelines, when the AI should be decision support, so it suggests the answer to be the result to be taken, or it's the decision taker, so it just takes that decision. So interesting to get your thoughts then about how you can balance those two objectives.
So you mentioned very early building for behavioral change. This guy called BJ Fogg, who's I think a behavioral, he does behavior for product, right? He came up with the formula B equals MAT, where behavioral change equals motivation plus motivation multiplied by ability multiplied by trigger. So if you imagine there was a team we built an algorithm for, this is not just giving, this is as part of my consultancy work, where they basically had a real retention problem on their app, trying to get users to come back. And they used to sit and have a stand-up every morning and decide, make decisions on what emails they were going to send and so forth. So we built an algorithm that could improve that, but the algorithm could just do it itself. Or we personalized the algorithm, so changed the M on the motivation side and the ability. We called it Elliot, and the algorithm literally just put its suggestions on a spreadsheet, and the spreadsheet joined the stand-up, right? And so that was far more effective in terms of take-up and usage than, let's say press a button and then and so ultimately there's nothing worse than an algorithm sitting on the shelf doing nothing because you've spent money building it. So because it was essential to get that being used, otherwise they weren't going to see value in it. That's when you make that decision. Should we, does it help? Will the team block it? And so the team were much more effective at using it by having it appear in the stand-up every morning. What's really interesting from that is over time, they built so much trust with Elliot that it didn't need to show up at the meetings anymore, and Elliot could make those decisions. So there's a couple of really big, I work with a lot of product managers for startups and tech companies. And one of the things we say is without trust, the machine will never get used, right? So it's what are the things you have to do to inspire trust in the machine, trust in what it's delivering. And one of those is giving us as humans access to correct it. Because we came across some psychology papers where they're saying one of the reasons we don't trust machines is because they never get punished, right? Whereas we do, yes. So you could inspire trust by allowing the user, both the user internally or externally, by allowing them to correct the machine. So you'll see some sites that say, did I get this suggestion right for you? And giving it, so it's empowering the user in that way. So those are some of the techniques I've seen to try and address that.
And I guess when you were getting Elliot to bring the suggested suggestions on a spreadsheet to the stand-up meeting, that was a way of still empowering the marketing experts, the rest of the experts. Yeah. They were still valued, So again, it's subtly trying to avoid them suddenly seeing as a big threat, AI is taking my job away.
Yeah.
It was actually allowing, presumably, their wisdom, their experience to be built in and fine-tune it.
Yeah.
And when they trusted it, they could then move on to greater things.
Yeah. So it's like you said, decision support, I think was that. And I wonder if actually there's a continuum rather than either or. Perhaps it's a good place to start with decision support because we still don't know if we have all the right data. Although it might be effective from an assessment and an accuracy perspective, but actually through it being used for decision support, we may gather more information and more data that can be used to improve the accuracy of the algorithm.
Yeah. Good. Okay, a question, gentleman, just over there, and then we'll come to you at the back.
Hi. So I used to do a lot of recruitment for a large bank, particularly around data scientists, and the mandate that came from on high was to recruit based on three priorities. One, their data science ability, two, their soft skills, and three, their general computer science ability.
Right.
And the third was weighted probably higher than one might expect, to the point where we have very, very gifted mathematicians and data scientists on the phone, but if they couldn't tell us, let's just say, what third normal form was, or
Right.
what object-oriented programming
Yeah.
is, or what that bash thing does on Linux, we wouldn't hire them. Want to get your take on that. How much do you think that data scientists should be proper computer scientists, or do you think they really are a special case?
So, so we moved them away from having to do any computer science or full development. They have to have enough to be able to write the algorithms within Python or any of those sort of things. I prefer that because you've got a much wider pool, right? If you want them to be able to write enterprise-grade code to be able to work on a platform with 100 million users and write proper sophisticated algorithms that have been tested properly with right accuracy, recall, and precision, you're in unicorn territory. And you said soft skills as well. That you're going right back into that space. They're hard to find. I think even I'm almost, because it's being recorded, I could almost say that they don't really exist because you spend so much time in one of those areas. So I haven't written an algorithm for ages now. And I don't think I could as well or as quickly as, it'll take time for me to get back to that because I've spent a lot of time with executives, right? And I just don't know how you can do all at the same time, And so we created 4 distinct roles. We had the business analyst whose job was to effectively be that intermediary, or some people call them the business partner. We even took out the requirement to work with large amounts of data from the data scientists and just said, you know what, we'll have strong data engineers. These guys have the ability to manipulate large amounts of data in the cloud platform really, really quickly and really, really easily. We were lucky that those guys as well were really good at sourcing data, because that's another thing that when you're in data acquisition, where's the data? How can they just go write a script that will go and get it from here and then neatly put it in this tabular form? So we had data engineers whose job it was really get the data and get it ready for the data scientists. Everyone wants to do a little bit of data science, so they all touched a little bit on that, which was really useful because when the data engineer was preparing the data, he knew what he had to do to reduce that. They always say a data scientist spends 80% of his time or her time preparing data. So the KPI for a data engineer was reduce that time, right? So get that data ready quickly. And then leave the data scientists to work on the algorithm, work on the models, the model selection, model accuracy, and making sure they get that to, training the machine and getting that to work. And then another group of people for deployment. I just couldn't get a data scientist that could write an algorithm and then write code that we could put on Just Giving. You've got millions of users coming onto the platform and it would work. That would, yes, it was just really, really hard. Having said that, data science is becoming one of those skills that you can learn quite quickly. It's this is debatable, okay? But an algorithm is a couple of lines of code. It's making sure you understand how you get that data ready, how you evaluate the model, how you select which models you're going to use, and how you can allow it to train and that sort of thing. So increasingly, you're seeing a lot of people being able to learn some of that discipline, and some tech is also making it a little bit easier. So I wonder if we might be able to get developers to do some of that as well. So your enterprise-grade developer who can do a bit of that. They may not be a specialist though. So they may stick with linear regression rather than including logistic or bringing some of the other the trees or the deep learning neural nets into play and that sort of thing. So.
Sorry, gentleman in the blue shirt and back in.
You talked about how important it is to get the education within the organisation right,
Yeah.
and also mention the importance of getting the user experience right. I wonder what your thoughts are on about how to approach explaining what you're doing to the customer or the end user, both because you can get customers who are somewhat underwhelmed because they expected more, like chatbots, for instance. Or equally, end users who are a bit creeped out by it.
Yeah. Yeah.
So I was wondering how you thought.
So yeah, I do a whole section on trust, and that's what I put all of those under trust, and it's there's certain principles I told you, the ability to correct the machine, but also to be very clear with the user and say I'm a machine, and add vulnerability to that. I may get this wrong, almost seeking forgiveness before you even start. With chatbots, there's actually an interesting framework, and I can't remember the name. I'll try and dig it up, where they talk about the humanizing of the chatbot when it's interacting with people, and there's a good framework of how that happens. And I think a lot of those things can be used on the product side of things too, where you can see, but a lot of companies were doing that when they put a recommendation, for example, and allow you to correct it, allow you to say this was correct or not. Or they add some greater context to that. We're showing you this because of this. Although that's an interesting personal one as well from behavioral economics. So if you're from a very, let's say, let me call it inclusive, I think it is a very inclusive society. So let's say like Korea or something, where if you show the user 50 of your friends have done this, they're more likely to go ahead and do it. But from Western cultures who are more exclusive, I think it is, I can't remember if those are the two terms, forgive me if I've got the wrong, where actually you can't show them that because they'll be like, well, I don't want to fit with the crowd, I want to be exclusive. So you say, be the first, right? and things like that. So there's some interesting things that I've seen done there with machines.
Yeah, good. Richard, I think.
Just coming back to the question of skills,
Yeah.
I was at Big Data London this week, and a lot of people talking about citizen data scientists. There's a lady from Google, Watson, that kind of they're pushing this line that the tools are just getting so easy, and data science is just going to be kind of automated out of existence, and so anybody with a kind of with a maths degree can just pick it up and do it. And you don't need these incredibly expensive guys anymore. What's your take on that?
If you just glance at what a data scientist is supposed to do, you could easily say, yeah, maybe a machine can do that.
I think Watson's probably doing slightly more than just
but there's, you need a level of discernment when you're building a model. Okay, so it may work in testing, as I said. You followed the rules, you've got your data right, which is typically what some of these tools do, right? So they allow a civilian to just take data, structure it in the way that the algorithm likes it, talk about the result that they're trying to get, and then it selects the algorithm and it does it all for them. But they don't know how to control for this or control for that, right? So if you have a distribution that's incorrect, so let's say you're looking at average salaries as one of your features, and Bill Gates is in the room, so the average will be significantly higher, but that's because we have an outlier, right? So to do that trimming and to do that, well, I suppose as I'm saying it, you can probably train a machine to do that because you get it to do a distribution on every feature, but it doesn't know what all the features are. So I think there's some way to go, but thinking about it just off the top of my head, I think it could possibly be. I struggle to find a use case that a machine can't do just yet. Maybe there'll be some time. So can a machine pick its own algorithms for certain things? I think potentially yes. I think will it be a time when data scientists aren't needed? Well, you need them now because you need some of that discernment when you're building the algorithms. Will it happen in the future? I don't know. I don't know just yet.
I think from my perspective, I think there's still that need for insight, that need for domain expertise. So if you've done a plot of something and there's an outlier, then the insight might be that outlier is something interesting. I want to find out what that is, and that might be the opportunity. The AI might look at, that's an outlier, I'll filter it out.
I'll just trim it, yeah.
So you have to be sort of mindful of how that's being done. There's a question somewhere over here, is there?
Can I just add to that as well? Sorry, just before that. One of the things a machine can't do is to know whether that's all the. So you give it a set of data, and it said that's what I'm learning from. So I can choose which variables, which features are significant, and which ones aren't, which ones have high coefficients, which ones don't, right? But it doesn't know that actually, if it had, unless you give it, if it had this, that might be really interesting to add. You know, if we added gender, if we added this, if we added all of those different things, it might not know that off the front.
I think if it was saying that any idiot could do data science, but I think they were sort of implying that the kind of highly specialised knowledge that data science has required up to now
Yeah.
won't be necessary, and that the so-called citizen data scientist will be doing exactly what you're saying, providing the context and the interpretation around that, but maybe a little bit of broader pool of people capable of doing that.
Yeah, there's definitely a possibility. I think the more we're talking, it's one of those that we'd have to just keep discussing, because the more we're talking, the more I'm thinking, well, what about this and what about that? So I'm even thinking about, in the instances that we've explained, we're talking about one model for one problem. But what about hybrid models or bespoke models, which is a whole mix of them, you know? So a bit like AlphaGo's, you know, a reinforced plus deep learning, you know, and adding all of those things together to be a bit more effective. An example that came to my head was, and I hope this is relevant, but if we think about the Netflix competition where they were like the $1 million prize for anybody who could improve their algorithm, there was an example where you had a whole bunch of sophisticated people writing really sophisticated algorithms across that data set. But the team that won it used the simplest algorithm, and added a layer of intuition by getting IMDb data, I think it was, or something like that. So I don't know how it'll take time for the machine to think of some of those sort of things. Yeah.
Thinking on the skills side, I think for many organisations there are lots of spreadsheets, and the spreadsheet jockeys very often are self-taught. I think what you suggested there, Richard, is almost the citizen data scientist. The risk there of the gifted budding amateur who's maybe a bit over-enthusiastic. And how do you actually help people on a path so they can get the skills more formalised, so they can be effective if they do have that underlying capability that they could be a data scientist?
I don't know the answer to that.
Fair enough.
Yeah.
Yeah. An imponderable one there.
Yeah.
Mark.
Can I just say, so Mark's talking about BCG. Take it up a level. If you go to non-techie conferences, I think we built environment conferences, there'll be one speaker who says, oh, what's coming over the list? Artificial intelligence is going to take the hook. And then you get another person stood up who then slags off artificial intelligence, says it doesn't exist, and starts talking about machine learning. Where do you sit? Does AI exist, or is that just the term that everybody outside of this room understands? Where do you sit with the term AI?
Yeah. So you know what? It's one of those that, if I'm honest with you, I don't know if anybody will agree. You know what the differences are, or any of those sort of things. I look at it as really simple. Artificial intelligence is, the process by which we're trying to simulate human intelligence, right? Machine learning is just a subset of that. You can't do AI without machine learning, because the machine has to learn how to do those sort of things. So if you want to create a very clear distinction between the two, then some people can do that. Essentially, for me, it's the same family of technologies that are achieving the things that they're doing today. I tend to stay away from that debate, because I'm not sure what it adds for me at this stage. Right? It may do, but I don't know what it adds.
I think people almost want to sit there, and it's normally people who don't understand who then say AI doesn't exist.
Yeah.
Because this is sense of repeat.
Yeah. And there's also, Hollywood has a lot to answer for making AI look like, ASI rather than just the narrow AI that we're dealing with right now, which is what and I haven't seen much work in even artificial general intelligence just yet. So, although there's some interesting thoughts as how far away that is, then that's another whole debate, right? So.
There was a presentation I attended a while ago, and that artificial general intelligence, I think it was many, many decades, probably centuries away, but just thinking through all the problems that have to be overcome to try and get there. Yeah. So it's certainly not on the near horizon, but I think it's a good point there of where are we going, how far are we going, and how fast.
Yeah. So even things to think about on that, such as machines right now can see, they can hear, you can codify taste. But that's also assuming that we as humans only have 5 senses. And I think from what I've seen now, we have, is it 21 or something like that? 21 different senses? So even things like, let's see if it works here. If you close your eyes and try and point at your nose and touch your nose, did anybody miss? No, really? So that's another sense apparently that doesn't fit within any of the 5 that sometimes we haven't really considered, or even that thing that when you walk into watching a movie and you know who the bad guy is at the beginning, right? You know who the bad guy is straight away. What's the signal that sent that across to you? So it's trying to codify that gut, which doesn't sit in many databases right now, right? And so. There's some way to go, I think.
Yeah, I think it's really interesting. So just to codify that and get into a database is first somebody has to understand it.
Yes.
And understand it well enough to work out, well, what data supports, if we have identified a 6th or 7th sense, what data supports that? So yes, there's some interesting long journeys there, I think. Yeah. Any more questions from the floor? Yeah.
First one. So what's your view on open sourcing a lot of these models? So I think particularly within the OpenAI group, they open source, they were going to open source GPT-2,
Right.
which is effectively the algorithm writes a news article, for example. They chose not to open it, so they felt it was too dangerous. What's your view on that?
Yeah, it's I used to be like, look, open source everything. But then with some of the things that we've seen at the, let's say, elections or things like that, until we have a mechanism to properly police some of that stuff, I don't know how valuable it is to fully open source, particularly since now we have very clear evidence that there are people who will take those algorithms and use them for other things. You know, if I told you can get an algorithm that can manipulate how much someone's going to donate, open sourcing that and finding, well, okay, then there's probably people out there who will say, I can probably think of a use case for this that may not be in the same social sphere, right? Personally, it would be useful for us and governments to start spending time on how do we police some of this stuff? What frameworks can we put in place for that? And then, by all means, open source. Because the other thing that you get with open source is you get creativity to solve problems that no one else had thought of. So it's that balance, right? Tricky one.
I guess it opens up that data ethics question quite clearly there of most of us in the room hopefully would act ethically, but there are people out there who will try to act unethically as much as they can. So yeah, it's a very interesting and difficult space, I think, potentially. Yeah.
So coming on from that, actually, so keep knowing I work for CGI. We've lost a lot of data scientists.
Oh, to Facebook.
Coming on from this ethical question, what about the legal question? So what were the challenges you had around making sure that harvesting those large data sets, you had the right permission, you were within the constraints around
GDPR. Yeah. No, I'm all for that. I think it's I wasn't one of those when GDPR was coming thinking, oh, now we're not going to be able to do any of our algorithms. I think we've got to be as transparent as possible. And look, if you can convince me that your algorithm is going to help me, then I'm okay with it. If your algorithm sounds like it's taking from me, then So I'm all for, look, we went and were very extensive about the fact that we wanted to enhance your giving experience and make things as personal to you as possible, and that's how we were going to do it. So.
Oh, it was interesting. I was at a conference last year. There was a representative from the Information Commissioner's Office, an AI conference, talking about what their expectations would be for organisations building algorithms to explain what they were actually doing with data, where they were sourcing it from, to demonstrate that they were compliant, basically.
Yeah, but you had some interesting points on that, which we were talking about earlier, in terms of like what you put in that disclaimer and how many people read all of it.
Well, yeah, there's slightly changing in terms and conditions. 50-page document and everything they're going to read, aren't they?
Yeah.
They just accept it because they want to use the product to continue.
I think you raised an interesting point there in terms of, again, going back to that explainable AI perspective of, do you get the AI to explain itself, or you were suggesting there that you have a separate explainer bit of AI, and how do you know that actually the two of them are in sync? They might say, oh, we made this decision because, but actually the AI might have gone a different route to get that same outcome. So, I mean, should all AI be explainable?
Yeah, well, okay, but what if you build an algorithm that can solve cancer, but you don't know how? Would we say, oh, we don't release it until we know how? It's a hard one. I think my natural answer to that would have been yes, all AI should be explainable, but there are some scenarios where it's actually quite useful like that, where it isn't. But then there's other scenarios where, you know, they've got algorithms that can put a propensity on your likelihood to be a criminal. I think it should be clear how it's coming up with some of that, because if it's using data like the one Compass, I believe, in the US is using, me walking into a room, my propensity goes higher because I'm black, right? So it's useful, I think, for some things to be pretty clear how the machine's coming up with it. Yeah.
Just wondered, what are the key skills, soft skills, do you think the roles within this sort of thing, like the PA, the data engineers, and the data scientists should have the critical skills, and do you think one of those should be knowledge of neuroscience?
Knowledge of neuroscience is pretty essential if you want to do if you really want to get into the nuts and bolts of deep learning. I actually found that some of the best data scientists that I've come across were actually psychologists by trade. I think it's essential. Machines are being trained to make decisions, which is what we typically do. Someone who has a better understanding of the human condition and how we operate, I think will always have an advantage over someone else. Is it necessary for a business right now to recruit someone with that background? I don't know if it's necessary, but definitely someone who has a better understanding of people will have an advantage. So this is why behavioral economics was really quite essential, particularly for, and not just for consumer-driven AI products, even internal ones, because ultimately people are using them, or they're going to impact something that someone has to do, right? As decisions can impact an action. Is it essential? I don't know. I don't think you shouldn't hire one because they don't have that, but I think you should make sure.
It would add to value to the...
Add value, yes, absolutely. I think so. Yeah, and perhaps even the accuracy and the success or the impact of it, yes, yeah, definitely it will add value. Just like I said when we added behavioral economics, it made what we built far more effective. So.
Yeah, good. I think we're running out of time, so just time for one more question. So I'll go back to our gentleman over there.
So we've spoken a lot about ethics and a bit about governance. Do you think it's a source of concern how far behind government and regulation seem to be? You know, if we think of technology advancing at an exponential curve, government seems to be down here and kind of chatting about the aftermath of these things.
What do you think on?
Do you agree, and like, what should we then take away from that? Is there a route forward?
Yeah, I think, as you said, tech is moving so fast, and keeping up with it is a challenge, right? What's even more disappointing for me is how many execs, government officials, so the non-tech people who are like, it's just not something I need to worry about right now. That's a real issue for me, you know, especially when we can see how quickly this stuff is moving. And it's obvious, it's not doing it covertly. It's pretty clear how fast this thing is moving. You know, we had self-driving cars was a university exercise for DARPA, right? And, you know, within 1 year, they went from, if you remember, they did that competition around 2005 when they had all these universities build self-driving cars and see who could, across the Mojave Desert, I think it is. And the first year, none of them did it. By the second year, all of them did it, you know. And then after that, all these companies have self-driving cars now, right? So it's moved from a university research exercise to something that's commercial. This is happening right in front of our faces. So I get really disappointed when I hear government executives and so forth just say, it's, you know, taking their time about it when they really should be at the forefront. You can see from the questions that Mark Zuckerberg was getting, the gap, right? that really needs to be addressed, really needs to be addressed. So.
Good. Right, well, we're out of time now, so thank you, Mike. So just join me in thanking Mike, because it's been excellent.